the binomial expansion, the binomial theorem example 4. Find the coefficient of x to the power of 5 in the expansion of this complicated expression. So you see, this is a product of two brackets. One of them is actually raised to the power of 6, so perhaps we will be able to employ the binomial expansion for the second bracket and leave the first one without any change. So let us copy what we have. So we have x plus 3 times 2x minus 1 to the power of 6. Now I can express this as a binomial expression, but before I'm going to do that, I do not want to write all 7 terms there. So you know that this will contain 7 terms, this bracket here. Okay, so let me try to express the general r plus first term, r plus the term with index r plus 1. Okay, so if I want to do it, what I need to do is to write the general expression, which is n choose r, in our case 6 choose r, times 2x to the power of to the power of 6 minus r, times negative 1, which is b is here, negative 1, to the power of r. So this is the general expression for the term in this expansion. Now we are interested only in those terms which can produce x to the power of 5. So imagine you have this expression here of the binomial expansion of this second bracket, and now you are going to multiply by x. So if you multiply by x, which is to the power of 1, which term do you have to multiply so that you obtain x to the power of 5? Well, the term which contains x to the power of 4. So we are interested only in this term of this expansion of the second bracket, which contains x to the power of 4, because when it's multiplied by x, you get x to the power of 5. And also, imagine that you are multiplying by 3. If you multiply by 3, then it doesn't change the power of x. So also we are interested in the term containing x to the power of 5. So there are two terms of this binomial expansion of the second bracket which are interesting for us, x to the power of 4 and x to the power of 5. Okay, so let us learn which ones are those terms. So if I want the term with the fourth power, let's solve this. Here 6 minus r has to be 4. 6 minus r has to be 4, because this is the only factor which contains x. So it means that r has to be 2 in this case. And when r is 2, then we are talking about the third term, 2 plus 1. Okay, so it's the third term. And the third term has the expression 6 choose 2 times 2x to the power of, as we said, 6 minus 2 is 4, times minus 1 raised to the power of 2. Minus 1 raised to the power of 2, since 2 is an even number, is just 1. So this would be the term, the third term. Now, for the situation when we have the x to the power of 5, we need to learn when it happens that 6 minus r is 5. And you see, it happens when r is 1. Okay, when r is 1, 6 minus 1 is 5. So it means that we are interested in the term t1 plus 1, which is t2. It's the second term of the expansion. And this is going to be 6 choose 1 times 2x to the power of 6 minus 1, which is 5, times negative 1 to the power of 1. So it's minus here. Okay, so we have the two terms. So what we need to do is the following. Let me come back to this. We have x plus 3 times the bracket which contains the expansion of this to the power of 6, and in this bracket there are some terms, plus there is this term which contains 6 choose 2 times 2x to the power of 4, plus there is somewhere this term. Well, actually they are in different orders, so let me write it again. So first of them is the second term. Here was the t sub 1, then we have the second term, which is not even plus, but it's minus 6 choose 1 times 2x to the power of 5. And the next one, it was the second, and the next one is the third, plus 6 choose 2 times 2x to the power of 4. Plus, there are some other terms. Okay, this was the first, second, third, fourth, and we have altogether we have 7 terms. And now the question was, find the coefficient of x to the power of 5 in the expansion. So now I need to multiply. So when I multiply by x, both of those terms, well, actually when I multiply by x, I have to multiply this, which will produce x to the power of 5. So the term which contains x to the power of 5 after the multiplication by x is going to be obtained from this one. So it's x times 6 choose 2 times 2x to the power of 4. Okay, so this is the term that has the power of 5 and is obtained from this product by multiplying the bracket, the square bracket, by x, and then we can get another term with the power of 5 when we multiply this square bracket by the power of 3. But it will produce the power of 5 when we multiply this term. This, if it was multiplied by 3, would have just the power of 4, so we ignore it. So what we need is minus 3 times 6 choose 1 times 2x to the power of 5. So these two terms in this product, which will be containing much more terms, these two terms will have the power of 5. So now let us try to evaluate those. So first of all, 6 choose 2. Using my calculator, I can see that it's 15. So I have 15x, so x is copied from this position here, times 10 to the power of 2 to the power of 4, which is 4 times 4 is 16, so it's times 16 times x to the power of 4, minus 3 times 6, because 6 choose 1 is just 6, 2 to the power of 5 is 32, times x to the power of 5, plus there are some other terms which we are not interested in. Plus, now we have to multiply 15 times 16, and we get 240, altogether x to the power of 5, minus, and now we have to multiply 3 times 6 times 32 to get 576 x to the power of 5. And when this is put together, what you get is 240 minus 576, and you get minus 336 x to the power of 5. Okay, so this is the term in this expansion, in this product of the bracket and the power of another bracket. This is the term which contains, and this is the only one which contains x to the power of 5. And the question was, what is the coefficient of this term? And we see that the proper answer to this would be that the coefficient is minus 336. So this is the answer to this exercise.